Good afternoon, everyone. I'm Steve,
I'm Scott.
and together we're Backyard Musings, broadcasting live Apple Valley, California.
Science and technology today, as always.
As always, not the experts.
Definitely not.
All right, melting sea ice changes not only how much light enters the ocean, but also its color, disrupting marine photosynthesis and altering Arctic ecosystems in subtle but profound ways. As this current ice age progresses, now they said climate crisis. I changed it to ice age.
Oh,
I couldn't stand climate crisis.
I like that movie, by the way.
As this current ice age progresses, it causes sea ice in the polar regions to melt. It is not just the amount of sunlight entering the ocean that changes. The color of the underwater light shifts too. This has major consequences for life below the surface, according to new research published in Nature Communications. These changes could significantly impact tiny but vital organisms like ice algae and phytoplankton. Would you like to know more?
So the key word in that last sentence that you read is could, right? Because this stuff's been going on forever, right? I mean,
exactly. So they're just reporting on it so that we know.
Yeah, exactly. So, but I mean, whether it's a crisis or possible, I mean, we don't know that, right? They're just taking a.
Well, we explain in here. They explain in here why the ocean's blue.
Yeah, isn't it reflection? No, that's the sky is blue because of reflection. No, the sun.
How much
the water?
The ocean breaks up the light, and blue is predominant.
Right. All right. The international team of scientists, which included physical chemist Sander Woutersen and collaborators from the Netherlands and Denmark, explored how melting sea ice transforms the underwater light environment. Light behaves very differently in sea ice compared to open water. I didn't realize that. Maybe it's because it's ice and the light refractions and stuff.
I remember the Great Lakes. I'm born and raised in Michigan. The Great Lakes, they were like a light bluish. They weren't like a dark, deep blue, even though the lakes are deep,
And they're almost like a sea, right?
Yeah.
I mean, you guys have.
Well, you could call it like the Sea of Galilee, the Sea of Lake Huron, Sea of Lake Michigan. Sea ice reflects and scatters most sunlight, letting only a small amount through, but the small amount includes nearly all visible wavelengths. Open seawater, on the other hand, absorbs reds and greens, while allowing blue light to travel deeper. This is why the ocean appears blue to our eyes.
Another key difference between ice and liquid water lies in the role of molecular vibrations. In liquid water, H2O molecules are free to move and vibrate, which leads to the formation of distinct absorption bands at specific wavelengths. These bands selectively remove portions of the light spectrum, creating gaps in the light available for photosynthesis.
That's very nice of the sea to do that. Previous research by Mikey Stomp, not making that up, or maybe it's Makey.
Mikey Stomp?
Yeah, Makey Stomp and Professor Huisman demonstrated that these molecular absorption features create spectral niches, distinct sets of wavelengths available for photosynthetic organisms. Phytoplankton and cyanobacteria have evolved a diversity of pigments tuned to the special spectral niches, shaping their global distribution across oceans, coastal waters, and lakes.
In ice, however, water molecules are locked into a rigid crystal lattice.
Yeah, we know that.
Yeah.
Ice cubes.
This fixed structure suppresses their ability for molecular vibrations and thereby alters their absorption features.
That makes sense.
Sure. As a consequence, ice lacks the absorption bands of liquid water, and hence a broader spectrum of light is preserved under sea ice. This fundamental difference plays a key role in the spectral shift that occurs as sea ice melts.
As sea ice disappears and gives way to open water, the underwater light environment shifts from a broad spectrum of colors to a narrow blue-dominated spectrum. This spectral change is crucial for photosynthesis.
Quote, the photosynthetic pigments of algae living under the sea are adapted to make optimal use of a wide range of colors present and little amount of light passing through the ice and snow, says lead author Monica Soja Wozniak.
Related.
Yeah, I wonder if she's related to the Apple guy.
Let's call her the Waz.
Okay.
Okay.
When the ice melts, these organisms suddenly find themselves in a blue-dominated environment, which provides a lesser fit for their pigments.
Huh. Using optical models and spectral measurements and mice, the researchers showed. I had to throw that in there.
We love the mice.
We love the mice. The researchers showed that this shift in light color not only alters photosynthetic performance, but may also lead to changes in species composition. Algal species specialized in blue light may gain a strong competitive advantage in comparison to ice algae.
According to Professor Hoosman, these changes can have cascading ecological effects. Photosynthetic algae, this quote, form the foundation of the Arctic food web.
Yeah, they do.
Okay. Changes in their productivity or species composition can ripple upward to affect fish, seabirds, and marine mammals. Moreover, photosynthesis plays an important role in the natural CO2 uptake by the ocean.
The ocean's a natural filter, man, grabbing that CO2.
It does.
Yeah.
It does. I mean, look at all the junk that we've done to the ocean, reported to the ocean. Oil and trash and
sunken ships.
It takes care of it. Yeah. It takes care of it. Again, it's been around a lot longer than we have.
The study highlights that effects of the ice age in the polar regions, notice I replaced ice age with climate crisis, in the polar regions does more than melt ice. It causes fundamental shifts in key processes such as light transmission and energy flow in marine ecosystems. The results underscore the importance of incorporating light spectra and photosynthesis more explicitly in climate models and ocean forecasts, especially in polar regions where environmental change is accelerating as an unprecedented rate. Yeah.
There you have it.
There you have it. You heard it first here. But I guess these guys were surprised by all the ice that formed in the Arctic just recently. There was a huge uptick of ice.
And we've been hearing about issues with that, right? Because it was all going to be, they were going to be melting away and raising the sea level. Who said that? Al Gore, right?
Was he the one that AOC, said that? A lot of people on the climate
said that.
Frenzy.
Yeah. So, and it's water's got to be colder to freeze ice, salt water, does it not, than it does fresh water, I think.
It's got to be colder, yeah.
Yeah, I think so, because of the ice content or the salt content. All right.
Yeah, the Earth goes through the natural. I mean, water's going to rise and water's going to go down. You know, it's not man-made. You know, it's been doing this for eons.
Yeah, man is just a blip on this planet, right? Just a blip.
We're just here for a short time, and then we go back to the eternities.
Yeah, look what they did to the dinosaurs, and they were mighty. So it's, you know,
and teeth.
Just watch yourself. Be kind.
Watch yourself.
Be kind to Mother Earth.
There you go. That's good advice.
But don't freak out.
Okay.
Like AOC.
Thanks, folks.
Take care, everyone. Thank you.